So, good evening all, welcome to Sakalavidya YouTube channel. So, in the last class we have discussed derivatives. So, now so far we have completed the 8 chapters. So, now this is the 9th chapter. Within actually 10 days we have completed the 8 chapters. So, now still yet to join our viewers, some new viewers are there today. So, good morning everybody, sorry good evening, Rishabh, hi, okay, Prasanna, Harshita Sai, and next we have Dhanusha, Swati Singh, VSK, Chandana, Behera, Prasanna, Ratnakumari, Preeti, okay, Vicky, Bilvika, Ratnakumari, okay, Tapsum, Lakshmi K, okay, hi. Okay, voice is not clear. Okay, now voice is clear. Wait. Now. Okay, now clear voice. Okay. Clear. Okay, thank you. Okay. So, once again any new viewers are there, subscribe and click the bell icon, you will get the subscriptions, and also the WhatsApp link has been given. So, you can join in WhatsApp group also, so that you will be getting notifications through WhatsApps also. Okay, clear. Thank you Chandana. Sandeep Neta, okay, clear. Thank you. Okay, thank you. Okay, Arvind Kumar, Sushma Reddy, thank you. Clear. Okay, Bhalu Bhalakoti, Dhanusha, now only I joined WhatsApp group. Thank you. Pooja Bhavani, clear. Okay, Pooja Bhavani, I think you are new to my class today, am I correct? Harshita Sai, okay, thank you. So, our aim is actually to give the free content itself only. We have been doing this one for last 3 years. We started in the year of 2015. So, that link is there, link available, just you check it in the link, you will get it now. Once again link will be forwarded last. Thank you Rishabh, thank you. Okay, good evening. Harshita Sai, okay, thank you Harshita Sai, thank you. Okay, Pooja Bhavani, I used to see offline classes, sir. Okay, no problem, thank you. Okay, Behra, okay. So, I cannot say actually, because I need to concentrate on the concept, isn't it now? So, they should have the minimum actually that tendency not to disturb others, isn't it now? Hare Narayana, okay. Thank you Pooja, thank you. Suresh, thank you. Subhashayantram, okay. Our link is given, see all of you. Good evening. Okay, can you give your contact number? So, contact number will be available in the following link, okay. Sir, you follow Telugu Academy. So, you follow Telugu Academy means Telugu Academy generally I follow, I have several books for reference. Presently they are not available with me. Siva Bhaskar Naidu garu, please don't chat, this is not a private chat room, please try to concentrate on subject itself only. Okay, Shravani, okay, Raju, okay, still some of our Arshita Reddy, please chemistry online EAMCET classes there, I don't have the idea. Sai Kiran, hi sir, okay, link is there, join link. Vaishnavi Vinayak, okay, So you have been waiting for 6:30, I think so. Okay. Thank you for our WhatsApp link. Thank you. Madhurima, good evening, Madhurima. So I am not able to get it. DVJK Murthy is there, isn't it now? Okay. Sai. Thank you. Let us start now today. Thank you. Okay, let us start the session now. Right now. Right. Okay, now see, generally the limit x tends to a f of x. So how to evaluate this one? So what is meant by limit x tends to a? So that means actually here x approaches to a here, or we can say that x tends to a. X tends to a. X tends to a means generally, for example, you take a number line like this. For example, a, the x may be tended from this side. This is called right hand side. So x may be tended from left hand side also. LHS, from LHS and from RHS, the x may be tended. Here that means actually we can say that this is x is close to a, but not x is equal to a. Sometimes x may be okay. Sometimes x may be actually equals to a. Generally x approaches to a, we can say that. So that means here whenever this LHS means whenever x approaches from this side, this is called left hand limit. X approaches from RHS, that is called right hand limit. So for that actually here left hand limit LHL is denoted by like this: limit x approaches to a minus, the symbol minus means that is left of a, f of x. For example, say this value is equal to something L1. So for example, if limit approaches from right hand side, that is called RHL. Generally we say that limit, symbolically we can write x approaches to a plus, suppose f of x is equal to, you say, L2. So if and only if L1 is equal to L2 is equal to n, then we say that limit x tends to a, f of x is equal to L. So then we can say like this. Understood now? So that means okay, left hand limit and right hand limit. So what are the properties of the limits now? So let's have a discussion now. So now the properties of the limits means properties of limits. Properties of limits. See, suppose limit x tends to a, f of x is equal to say L. Suppose limit x tends to a, g of x is equal to m. Okay. So now So, let us have a discussion. Properties of limits. Properties of limits. See, limit extends to a. Suppose f of x is equal to L, limit extends to a, g of x is equal to m. So, first point, limit extends to a k times f of x, where k is a constant, then that means here k into limit extends to a f of x. So, we can write this is KL. So, now okay, second one, limit extends to a f of x plus or minus g of x. So, now this can be written limit extends to a f of x plus or minus limit extends to a g of x. So, that means you can write this is L plus or minus m, you can write it. So, next suppose limit extends to a f of x into g of x, product of the two functions. Even if they are the product of the functions, then we can apply the limit for the first function as well as the second function. Limit extends to a f of x into limit extends to a g of x. So, this equals to, we can write Lm. Similarly, limit extends to a f of x by g of x. Here this is equal to, we can write limit extends to a, limit is applied for the numerator, limit extends to a g of x. This we can write L by m, where m does not equal to 0. Okay, now it is correct. Now we are not able to see right side. Okay, I won't write it there. Okay. Thank you for reminding me. Okay, I don't write. Little down I will write. Little down. Here okay. Right. Okay. So, I will repeat once again. Don't worry. I will repeat. Third one. Okay. Now, here third point is, I will write once again, limit extends to a product of the two functions f of x into g of x. That means this we can write limit extends to a f of x into limit extends to a g of x. So, that is equal to Lm. Understood now? So, now I think you got it now. Okay. So, next now let us go for another properties. So, now clear, thank you. So, fifth property, limit extends to a, suppose mod f of x, this is equal to, you can write, so mod L. Sixth property, limit extends to a e power f of x. So, this means e to the power of limit extends to a f of x equal to e to the power of L. So, in the similar manner, the limit of extends to a, so sine of f of x, even the limit is applied for this function also. So, sine of limit extends to a f of x. So, this we can write sin L. So, even log f of x, so cot tan f of x, cot f of x also same thing can be followed. And one more important concept is sandwich theorem. This is very, very important. Sandwich theorem, sorry, sandwich theorem. Or squeeze principle, squeeze principle. So, what is the sandwich theorem means? So, let f of x is less than or equal to g of x, g of x is less than or equal to h of x. That means, g of x is the sandwich between f of x and g of x, f of x and g of x. Suppose and here limit extends to a, f of x is equal to L equal to limit extends to a h of x, then limit extends to a g of x also L. This is the sandwich theorem. So, this we need to remember. Okay. This is the sandwich theorem or squeeze principle. Please, all the intermediate students who are going to write EAMCET, you guys must and should follow the live session. Note, I passed intermediate with 90% because of this channel videos. Sheikh Samir, thank you Samir. Okay, okay, thank you. Okay. Okay. So, now indeterminate forms, indeterminate forms. So, what are the indeterminate forms? So, 0 by 0, next infinity by infinity, next infinity minus infinity, next infinity to the power of 0, next 0 to the power of 0, next 1 to the power of infinity. So, these are called indeterminate forms. These are called indeterminate forms. Okay, now, for example, Hospital's rule. Hospital's rule. This is very, very important to evaluate the limits. Hospital's rule. So, what is the Hospital's rule means? For example, here see, if you want to find out limit x tends to a f of x by g of x form. So, that means if this will be either 0 by 0 or infinity by infinity, so then only we can apply the L'Hospital's rule. Understood now? So, otherwise we need to make 0 by 0 form or infinity by infinity form. Okay. So, that means actually here what is the L'Hospital's rule means, limit x tends to a, limit x tends to a, derivative of numerator by derivative of denominator. Again, for example, if it is 0 by 0 or infinity by infinity, again you can differentiate it. So, as we get the finite value, limit x tends to a f double dash x by g dash x, g double dash x. Suppose again this is 0 by 0 or infinity by infinity, then again you will write limit x tends to a f triple dash x by g triple dash x, and it will be continued till we get the finite limit. So, this is called L'Hospital's rule. And one more thing, actually once again L'Hospital's rule. Okay. For example, here remember, limit, if you want to find out, evaluate limit x tends to a f of x by g of x, if limit x tends to a f of x, limit x tends to a g of x is 0 by 0 or infinity by infinity, then you need not, sorry, video is not clear, it will be coming, wait. So, now you need to differentiate, we should not apply u by v rule, separately numerator and denominator we need to differentiate it. Again substitute the limit, if you get the finite limit, stop. So, otherwise again you differentiate it. Now substitute the limit, if you get the finite limit you need to stop, otherwise you need to continue till you get the finite limit. This is called L'Hospital's rule. And one more thing, so before that I would like to discuss even one important discussion we have. For example, x approaches to a, x approaches to a, or for example you can say like this, x approaches to 0, for example. X approaches to 0 means x becomes very negligible value, very small value, that means negligible value. That is why, for example, whenever sin x is there, as x approaches to 0 means x becomes very small, then sin x approximately equal to, you can write x, sin x approximately equal to x. So, in the similar manner, the tan x also approaches to x only. For example, you remember this one now, x is negligible, x is negligible. So, you remember this one now. So, that means, for example, this 1 plus x whole to the power of n is there, this approximately equal to 1 plus nx we can write. For example, if you want to write 1 minus cos x, the 1 minus cos x is approximately equal to x square by here by 2, this 1 minus cos x approximately equal to how much, x square by 2 you can write it. So, that is why, see, now let us go for the some standard limits, so limits. we can discuss. See the standard limits. First one is limit x tends to a, x to the power of n minus a to the power of n by x minus a. So, you need not remember this formula, you need not remember. See, whenever in the case of cos, the cos 0 is 1, we should not write it, because sin 0 is 0, I have written x, understood now. So, now this is equal to, if you put x is equal to a to the power of n minus a to the power of n, 0, 0 by 0 form, you can apply L'Hospital's rule. Derivative of x to the power of n is n into x to the power of n minus 1, minus a to the power of n is constant 0, so 1 minus 0. Now, apply the limit, limit x tends to a. So, this is equal to n into a power n minus 1 for every n belongs to real numbers. Understood now? Simply we will get the formula. For example, limit x tends to 0, sin x by x. Now, tell me what you get. See, as x approaches to 0, the sin x is equal to x. So, x by x 1, that is all. But x must be in radians, x is in radians. Whenever it is radians only we can apply, otherwise it is degrees, you need to change into radians, you must remember. So, in the similar manner, the limit x tends to 0, tan x by x, now you can expect. So, 1, provided x is in radians itself only. So, okay. So, that means now standard limits we are discussing. So, for example, fifth one, limit x tends to 0, sin ax by x. Now, you can say, as x is very negligible value, sin ax is ax by a. Sorry, this is x, sorry, I forgotten. So, now the limit x tends to 0, tan ax by x is also a. So, now limit x tends to 0, sin ax by sin bx. See, as x is very negligible value, small value, here sin ax is ax by bx. So, x cancel, a by b. Now, limit x tends to 0, tan ax by tan bx is also a by b. Now, limit x tends to 0, now the sin ax by tan bx. Now, you can say answer. What is the answer? A by b. Okay. What is Sajida Begum? What is that? What do you mean by that one? What does x stand for? Okay. Now, the 10th one. So, limit x tends to 0, the 1 minus cos x by x square. See, this is already discussed. The 1 minus cos x is Okay, thank you. So 1 minus cos x by x square is, this is x square by 2, you see, x square by 2 and by x square. So x square gets cancelled, you get 1 by 2. Understood now? So that means now okay, now 11th one, limit x tends to 0, this 1 minus cos 3x by x square. It is very simple, you can write here 3 square is 9, by 2 write down. Similarly, for example, limit x tends to 0, the 1 minus cos 5x by x square. What is our answer? What is our answer? So that will be how much? 25 by x square. So that means limit x tends to 0, 1 minus cos mx by x square. So this is equal to m square by 2. Okay. Limit x tends to 0, the 1 minus cos mx by 1 minus cos nx equals to m square by n square. In bracket, n does not equal to 0. So understood now? So very easy problems. And one more you can remember, this will be very important. Limit x tends to 0, for example, you have like this, cos 3x minus cos 5x by x square. So this is equal to, we can write 5 square minus 3 square by 2, that is 25 minus 9 by 2. So that means actually here 16 by 2, answer will be 8. Okay. So now limit x tends to 0, cos 5x minus cos 4x by x square. So give me your answer in the chat box, all of you. Now it is visible, not visible? Prasanna, cos 5x minus cos 4x by x square. Yes, I have written right side. Okay, I don't write on top. Okay, this time. So, okay, I will move to this one now, better. Okay, now the 17th one. So now the limit x tends to 0, e power x minus 1 by x, e power x minus 1 by x. See, for example, let us substitute the limit. What do you get now? See, e power 0 minus 1 by 0. E power 0 is 1, 1 minus 1, 0. So 0 by 0 form. 0 by 0 form means apply LH rule. LH rule means L'Hospital's rule. So that means derivative of e power x minus 1 is e power x by x differentiation 1. Now apply the limit. Limit x tends to 0 is equal to e power 0 whose value is 1. You need not remember any formulae in the limits. Okay. So that means now 18th question. Limit x tends to 0. Now e power 2x minus 1 by x, this will be 2. Now limit x tends to 0, e power mx minus 1 by x is m. So limit x tends to 0, e power ax minus 1 by e power bx minus 1, this equals to a by b, this equals to a by b. Okay, right. So now the 21, limit x tends to 0, a power x minus 1 by x. Let us see this is. So if the form 1 to the power of infinity, we apply which methods are? Okay. So now this is actually, first let us substitute the limit. A to the power of 0 minus 1 by 0. So 1 minus 1 by 0, 0 by 0. So that means you can apply LH rule. So applying LH rule here, the limit x tends to 0, a power x differentiation is a power x log a to the base e minus 0 by 1. So now substitute the limit, a power 0 log a to the base e. So that is equal to log a to the base e. Okay. Yes, log a to the base e. And next, if you want to find out limit x tends to 0, now 3 power x minus 1 by x is log 3 to the base e, correct? So now limit x tends to 0, some a power 5x minus 1 by x, this is 5 log a to the base e. Now you can write limit x tends to 0, a power mx minus 1 by x is m log a to the base e. Understood now? So 25th, limit x tends to 0, this is a power x minus 1 by b power x minus 1. See, 24, 23 missed, why missed 4 sir, okay. So 16th one answer. Okay, I will come later. So this is limit x tends to 0, a power x minus 1 by x. So this can be done, divide both numerator and denominator by x. This we can write a power x minus 1 by x, b power x minus 1 by x. Now the limit is applied to both numerator and denominator. Actually limit follows the function, always remember. This is log a to the base e by this is log b to the base e. So this can be written log a to the base b. You remember Nana like this. Okay. Now I will give one example to you. Limit x tends to 0, 5 power x minus 1 by 2 power x minus 1. What is the answer? Please click in the chat box, all of you. All of you subscribed. This one now, 26th answer. 26th answer. 26th answer. Okay. So, this equals to, we can write log 5 to the base 2. Next, one more. Limit x tends to 0, a power x minus b power x by x. Okay, this actually you will get log of a by b to the base e, log of a by b to the base e. Are you checking? Okay. Next one, limit x tends to 0, 1 plus x whole to the power of 1 by x. So, now let us substitute the limit here. We get 1 plus 0, this is 1 by 0. This is 1 to the power of infinity problem. This is very, very important. You remember 1 to the power of infinity form. Generally, in competitive entrance examination, difficult problems will be given from this sector, 1 to the power of infinity problem. Yes, now, so this can be done like this. So, for example, you take limit x tends to a, f of x to the power of g of x. For example, this is 1 to the power of infinity form. This we can write e to the power of limit x tends to a, g of x into f of x minus 1, you can write it. This please remember, this is very, very important. Please note down this one. So, now this is f of x, this is f of x, see this is g of x, g of x. Now, apply this formula now. This is equal to e to the power of limit x tends to a, g of x means 1 by x into f of x minus 1, 1 plus x minus 1. So, here actually 1 gets cancelled. We have e to the power of limit x tends to 0, 1 by x into x1. If limit apply to the constant function, you get constant. So, e, that's option is e. So, that is the reason. This is 1 to the power of infinity form. So, we get like this. So, even 29th one. So, for example, limit x approaches to infinity. This 1 plus 1 by x whole to the power of x is also e. Sorry, instead of L'Hospital's rule, can we use factorization and rationalize? Okay, you can do it. You can do it. You can do it, no problem. Depends upon the problem. Okay, E, right answer, right. So, limit x tends to 0, 1 plus ax whole to the power of 1 by x. This is e to the power of a. So, actually Dhanusha, I will inform you. So, now limit x tends to 0, 1 plus 3x whole to the power of 1 by x is e to the power of 3. Okay. Limit extends to infinity, 1 plus a by x whole to the power of x is e to the power of a. Okay. Now, limit extends to 0, cubed root of 1 plus x minus 1 by x. What is this value? Anybody? Okay. Yes, 1 by 3. So, this can be written for our convenience like this. Limit extends to 0. This we can write 1 plus x whole to the power of 1 by 3. As x approaches to 0 means x is very negligible value. This can be written 1 plus 1 by 3 into x minus 1 by x. Limit extends to 0. So, 1 gets cancelled, x gets cancelled, 1 by 3. Absolutely correct. So, 34th, limit extends to 0, root of 1 plus x minus 1 by x. What is the answer? What is the answer? Okay, just type it in the chat box. No response? What is the answer? Yes, wonderful, wonderful. 1 by 2. Okay. Now, the limit extends to 0, root 1 minus x by 1 minus x minus 1 by x. What will be the answer? What will be the answer? This will be minus 1 by 2. Now, one more question. Limit extends to 0, root of 1 plus x minus root of 1 minus x by x. Okay, some of the viewers asked me, sir, we can apply the rationalization. Yes, generally we rationalize the denominator, but here we rationalize the numerator. By rationalizing also you will get it, but this one also we can apply. Here this answer is equal to, this will be half, this will be minus half minus half. So, you get half plus half is 1, answer is 1. Yes, Madhurima, right. So, 37th. This question was actually so many times asked in the examination. Cubed root of 1 plus x minus cubed root of 1 minus x by x. What is your answer? This is 1, 37. Just see it. So, now at least I need to get more than 200 likes. Everybody give the, okay, say again. Okay, 37th question. What is the answer? 37th question. 2 by 3. Oh, wonderful, 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 wonderful. This is 1 by 3 and minus of minus 1 by 3. This will be 1 by 3 plus 1 by 3. is 2 by 3. Absolutely correct. So, one more question I will give it. Limit x tends to 0, fifth root of 1 plus x minus fifth root of 1 minus x by x. What is our answer? What is our answer? I will wait. So, you need to type in the chat box. 38th question. 38th. 2 by 5. Yes, I will see. 1 by 5 and minus of minus 1 by 5. So, 1 by 5 plus 1 by 5 equals to 2 by 5. Absolutely correct. Next, now limit x tends to 0. Now, pth root of 1 plus x minus pth root of 1 minus x upon x. What is our answer? What's our answer? Ramakrishna. 1. Now, you check it now. 39th question. Ramakrishna garu. Yes, Madhurima, Prasanna, Sudha. Okay. This is actually 1 by p and minus of minus 1 by p. So, 1 by p plus 1 by p. This will be 2 by p. Okay. So, if they are different also you can do it, no problem. Okay, now sorry. Okay. Next one, see, suppose limit x approaches to infinity, then this 1 by x, 1 by x square, 1 by x cube and so on, 1 by x to the power of 4 dash dash tends to 0. You remember this one. Okay. So, now question here, limit x approaches to infinity, ax plus b by cx plus d. Just observe here. So, this is infinity by infinity. By differentiation also you can do it. Differentiation of ax is a by c, or you can remember like this, coefficient of x by coefficient of x. This is in numerator, this is in denominator. That is why answer is a by c, a by c. So, this will be useful for EAMCET also. So, next 41 question, limit x tends to infinity, this is 3x plus 5 by 4 minus 7x. What is the answer? What is the answer? So, this is coefficient of x is 3, here coefficient of x minus 7. So, 3 by minus 7 which equal to minus 3 by 7. Okay. So now the 42nd question. For example, limit x approaches to infinity. Suppose ax square plus bx plus c upon px square plus qx plus r. Here highest power you need to see, that is 2, that is why a by p. Okay. So now suppose we have limit x approaches to infinity, x square plus 5x plus 6 by 3x square minus x plus 1. What is this answer? Okay, Sanjarani, I will discuss later in the, okay. So now the coefficient of x square is 1 in the numerator, denominator is 3, 1 by 3. Okay. So 44th question. So now limit x approaches to infinity. For example, like this is there, x square plus 5x by x cube plus 7x square plus 4. Just small change you need to do it. Limit x approaches to infinity. Here in the numerator x cube coefficient is absent. You can write 0 into x cube plus x square plus 5x, you can write it. So upon this is x cube plus 7x square plus 4. So in the numerator highest degree is 3, that coefficient is 0, here x cube coefficient is 1, so answer is 0. Okay. For example, limit x approaches to infinity, something this is x to the power of 5 plus 4x by x square plus 7x plus 8. So this we can write, the limit extends to infinity, x to the power of 5 plus 4x. Here in the denominator x to the power of 5 is absent. So you write down 0 into x to the power of 5 plus x square plus 7x plus 8. This will be 1 by 0, that will be infinity, positive infinity. If negative is there, negative infinity you will get it. So in this way we can solve even polynomials also. So I hope you might have followed all these tips. We can't say that these are shortcuts. So these strategies we can apply for the problems, but moreover we shall solve the problems also, level 1, level 2, level 3 problems in the limits, because limits is very important chapter. That's why today is the actually practice session. So this 1 hour actually allotted to the practice session itself only. So once again you need to practice all these things. Definitely I have given lot of practice to you. So you might have subscribed and like and share. So thank you one and all. Bye bye. Stay safe. Stay at home. Thank you one and all. Thank you. Bye bye. See you.